Welcome to the Future Print session about challenges in customization for print production. In the next hour, you will get 4 perspectives on applied printing solutions and development approaches to novel technology. We will discuss a couple of challenges of integration. We'll get some very nice examples of applied technology, and we will look at some differences between startup tech and mature solutions. My name is Roland Biemans. I'm the founder and owner of LMNS. Our team of print industry experts assists with product and business development. We connect the dots between design, technology, and application. My guests in this session will explain what they bring to market and how. First, I will have a conversation with Carson Brinkmayer of Hummen. Hummen is known for solutions in digital decor print. Carsten will give his views on building bespoke printing systems for their customers. Next, I will be joined by Koen Santegoets of Integration Technology, and he will tell about their UV curing technology and the lateral approach to integration in novel application fields. I will continue to speak with Stefan van Waalwijk van Doorn. He's research engineer at TNO Holst Center, as well as CTO at Eindhoven-based startup Chiron. Stefan will touch the subject of transforming primary research to market-ready solutions. And then finally, Infocal CEO Robert van Dankeren will speak about a new take on laser-based marking to increase productivity, lowering environmental impact, and offering a non-inkjet opportunity that is fast and very precise. So I'm sure you will enjoy this session. So let's sit back and listen to what my guests have to say. So my first guest of this session is Carsten Brinkmayer. He's working at Hummen. So thank you for joining us.
Thank you, Roland. Thanks for having me here.
Yeah. So in this session, we are talking about the challenges in customization for industrial print. And Hummen is known for its dedicated printing systems for the interior decoration market, for one. Can you first introduce yourself and Hummen as a company?
Yes, thank you. So my name is Carson Brinkmayer. I'm working for Hummen since 2007. Started there for digital printing. I worked for printing manufacturers my whole life, printing machine manufacturers my whole life. I'm involved in digital printing since 1999, so quite a long time, I think. Hummen is building machines, especially or most for the woodworking industry, making the surface finishing. Hummen is based in Germany, Bielefeld, quite in the northern center, and we are building many machines which are involved in surface finishing, which are coating machines, presses, lamination machines for furniture boards, presses for flooring boards, coating machines, and since 2007 we built also digital printing machines.
Okay. So your approach to the market is slightly different than most off-the-shelf machine manufacturers, I would call them. So you make dedicated systems, and then in particular for the interior decoration market, right?
That's right. Because we are involved in many processes of that decoration market, from everything what's coming on top of a board. Our focus is really in the process chain, and everything we do in digital printing is single pass printing, so there's no multi-pass printing we have in our portfolio. And when we are looking to the digital printing, to implement digital printing in the processes of the customer, the process itself is very important. So maybe 10 years or in the very first beginning of human involvement in digital printing, there was the digital printing itself was a big thing on every trial with a customer.
Mhm.
But
Mhm.
more and more digital printing gets common, and the technology is ready for sure. Maybe more ready than 10 years ago. Um, and now everyone is looking to what's coming on top, what's coming before printing, how is the preparation of a board, and how I get the wear resistance for a flooring, for example. And this is what Herman is really, really looking for. And this is how we design our machines, especially for the market and for the customer needs. There is every time
Okay.
there is every time a standard parts. It's not really a standard machine. We like to build standard machines, but at the end, it's standard components. But yes, like a puzzle, feeding to the needs of the customer.
Yeah. So if you look at your typical customer or the typical segment that you're in, are there very specific requirements or very specific challenges that you have to cope with?
Yes, I think in the woodworking market, it is it's a quite special market. How the decorated parts come into the process. In the Actually, most furniture boards and floorings are built by printed paper, which is analog printed
Mhm.
paper, printed by it's five or six big companies worldwide, sharing most of the paper for that process. So the customer, the wood manufacturer, the wooden board manufacturer, is buying in printed paper and processing it, pressing it with melamine overlays to a wooden board. So yes, it is everything a long process change. So the designers decide to buy a finished design or to create with a printer a nice looking oak, for example. They do their sampling
Mhm.
on site of the printing of the printing company, and then it will be produced and it will be delivered. It comes into stock, and there are minimum order quantities you have to fulfill. You have to buy at least 1 ton of paper. Yeah, so it is not that you can say I have a
Right.
lot size of 200 square meters to produce. Um, and I just want to produce it, you have to buy in advance with delivery time a lot of material, put it in stock, and then use it partially. So this is the main driver, one of
Right.
the main drivers for digital printing in that market. So the lot sizes, the individualization is growing. The individualization, the lot sizes are uh, getting smaller and smaller. Um, and the variety of designs is exploring. Yeah. Um, so
Yeah, yeah, I can remember that in my own situation, I wanted to have a new floor in my house, and then I got to pick either two standards. One was with 6 prints inside, and the other one was with 12 prints inside. And then the repeat was something that sort of made that a premium or not.
mhm.
Nowadays, you can virtually get any type of print in such a wide variety. So your choice is much bigger. But then the question pops up, if that is then only a marketing thing, or if that's also a production chain change. So if you make a machine and you have to cater for that, it's not necessarily about the overall speed of the system or that you make one dedicated system for one dedicated customer, but it is about yeah, knowing exactly where those pain points are in that production chain, right?
That's right. So it is not only a question of speed. It is more, in our eyes, more part where the printing is in the process chain. The farther at the end you move the digital printing in the process chain, the easier it is to implement multiple designs or beam flexible, react on that. A very good example is that one customer is who's producing a lot of digital printing boards already is telling us that before digital printing, he was able to has an internal delivery time when his sales guy came in and said, "I have a 50,000 square meters flooring to sell for a DIY market." He had an internal lead time of 4 weeks. So they have to buy in the paper, have to buy in every materials to make it, has to plan it in this production and so on. With digital printing, he's able to do that in 4 days. Yeah, so
Right.
increased from 4 weeks to 4 days, and this is a real this is a big advantage against competition. So you can deliver within 4 weeks, in 4 days, sorry, instead of 4 weeks. This is a very strong argument for customers. And this works only up with this part, what we call decentralization. So not having a printer in place, printing papers, supplying it to different locations by lorry, by truck, and everything. And having the printer at the operation site. So the manufacturer of wooden boards become a printer. They are getting printer. This is exactly where we focus or we place our machines, either direct to board printing, which is the Jupiter, or the new Saturn printing lines, which is printing water-based inks on paper. Yes, one of the biggest challenges we are focused is that the not the customer has to be convinced to print digital. So everyone wants to print digital, but they have to understand that they need something which is fitting to exactly to their needs. When you, as an example, when a flooring manufacturer that today wants to have digital printing as part of his designs, for example, for longer repeats or special designs, he has three choices to go for this. He can buy in digital printed paper from one of these local from the central printing decor printers. They sell also digital designs, repeat lengths of 5.60 meters and everything. Very great things. This is one choice. He can buy in, but then he's still in the same production chain as his analog. So he has to order, he has to agree in a design, he has to agree in color, has to wait for the material, has a minimum order quantity. If not, then he has the same price as for the minimum order quantity. And then, yes, it's not the benefits of digital printing. You cannot have it very flexible. The second choice would be he's buying a multipass printer. And is doing his paper himself. Many producers do that, but we all know the volumes of multipass printing is not that high as a real manufacturing process needs. Yeah, we are talking about 100 square meters, 200, then it's a very good one. Typically the production line run with 3,000 square meters an hour. Yeah. So that would be the second choice. And the third choice is you buying a single pass printer and being a printer yourself. That is something many customers look for. And what they find in the market, what we've seen, what they find in the market are printing machines, which are coming from other markets like packaging, maybe textile, and so on, running with enormous speed, running with 150 meters digital, having a huge invest, also for sure, and they are capable then for produce 70 or 80 million square meters a year. Even the operations side is only producing 5 to 12 million square meters a year of their product. So at the end, the company does not need the capacity of the whole machine. And this is where then, for example, Saturn comes in place. We build a machine which is then designed for printing in a lower speed. Still a high speed in my eyes. It's printing with 35 meters digital single pass on 2 meter 20 widths, which gives you 18 million square meters a year. Yeah, this feeds nearly every single operation site in that market. But with that lower lower speed, everything gets easier. It's easier for the paper handling. It's easier for the drying capacity. It's no stress to the material. Also, print heads. We all in the printing industry know that printing with lower speed, the print head is not running at this full maximum speed. Everything works smoother, easier, more reliable. And this is where we focused to have the Saturn there as in this case standard machine. Even I said before, standard is not everything is not standard, but yes, designed
because
for the
essentially you're building for that customer what they need per their requirements. So even though you're basing it on what you would call standard, for every single customer you build what they need for their requirements.
Correct, absolutely correct. Yes, that's one of the biggest challenges is to place in the right spot.
Right. So for now, that sort of wraps it up a little bit. In that you have explained who you are as a company, what you deliver, and what kind of challenges you look at. So, is there any last conclusion that you want to share with the audience?
Yes, it is. It is in my eyes. It's very important when you are looking for digital printing that you're really targeting the right machine for your special needs. And not only the printing is is one of the big important things. It's a complete package. This is the post process, the pre process, not from digital database, which is also very important, but also how do I get the board material prepared for printing? How do I get coating, surface finishing on top? And we as Summon focus on that completely. We have 2,400 square meters demo center where we do customer trials and process optimization with the customer. And this is one of the very important things you have to look apart from the printing quality itself.
Right. So for now, I would like to thank you for your insights. People that want to get in touch with you can do so because on your profile page are your contact details. So for now, I'd like to thank you for your participation and hope to see you soon again.
Thank you, Roland. Thank you.
So my next guest is Koen Santegoeds. Koen is business developer at Integration Technology, a company specialized in UV curing. So welcome, Koen. Good to have you with us today.
Thank you, Roland. Thank you for inviting me for this panel discussion. I think the Future Print Virtual Conference is a great initiative, especially in the world of today.
Yeah, for sure. So, can you tell the audience a little bit more about integration technology and what you do as a company?
Yes, of course. Integration Technology Limited, as part of the IST Metz Group, develops and delivers innovative, high-quality performance UV curing solutions for all printing, industrial applications. The UV systems, are provided by worldwide sales and support capabilities. Also, Integration Technology wants to be a partner for everybody by offering modular and customized solutions, which leads to more efficiency, higher quality, cost savings, and innovative products. I think with my expertise of strategical account and business development, I have the goal to extend the business in different market segments. I do this from a home office here in the Netherlands, where I cover the European market and support globally if applicable.
Okay, clear. So, this session is about customization challenges, and we've just heard from Carsten that Himmen is building dedicated systems for products of printed interior decoration, and this involves customization for almost each and every system they deliver. What does customization mean for you for integration technology?
Well, in the current markets where we are operating mainly, some applications can be fulfilled with standard range of UV equipment, of course, with the flexibility to change certain parameters like size or wavelength, addressing, or maybe a serial bus connection, etc. But some applications needs more specific attention to get the optimum result. I think at integration technology, the word customization means sitting down with a prospective client, understanding the requirements, and developing a specific system or system attribute to meet the demands of a specific application. It assumes that none of our standard products or even tailored versions of our standard products are suitable. However, we do try to utilize some of our standard components configured in a way to meet the requirements of the application and leaves a minimum of a new design work, which results in a high confidence of level in performance and reliability terms. It also makes it as cost effective as it can be.
So you have a full range of standard modules, and your colleague Holly spoke about a very specific application in a previous Future Print session. Could you give us some more examples where you have worked on challenges that really needed your expertise?
Yes, of course, there are many examples, of course, but for example, we have clients whose production line holds a valuable product in a stationary position. During the process, the product goes from one station to the next station for the next process. This is commonly called a step and repeat process. This causes issues for traditional bar type of LED systems, as they are specifically designed to cure moving substrates with a high intensity bar light source, whether it's UV LED or arc. In this case, we need to spread the light out over a certain area. It's important not to have hotspots on the substrate, which creates an uneven cure. Also, the area could be quite large, for example, the size of a desk or even much larger than that. In all cases, we will prevent to overheat a valuable product. So, as you can see, a very different set of parameters to a normal printing application. The biggest challenge we face is how lateral we can be in coming up with a solution. For instance, in the example I mentioned before, an alternative way of curing the whole area could be scan the UV light head across the product when it's in the process station. This has the benefit of using a normal line source of UV, but it also has the added complication of developing a movement system, and it doesn't cure the whole area at the same time, which could result in unwanted attributes in the cured material. And that's the last thing the customer wants.
Yeah, indeed. Yeah, you see, our industry has so many variations and yeah, so many different application fields. So the way that we see it now, that we're seeing a trend that there's more companies getting involved in dedicated printing solutions. So something that they may not have been into as a producer or manufacturer, but now would like to integrate print into their workflow. So the question then is, are there specific markets that you see with, let's say, highest demand of that kind of customization?
It's a difficult question, of course. Although from our company's history point of view, we see in the digital printing a lot of demand of customization, especially in the shape printing, for example. But we have experienced also customization in general in the gluing and the coating industries as well. The world, is simply changing faster than ever before, and new applications pop up like mushrooms to keep up with the customer's demands of special products or personal customization. The industries have to keep up with their production processes. And of course, or let's say we will support them in this. But to come back to your question of the demand of customization, it's generally spread over all the markets we operate in.
Okay, so that means actually we're in for a bright future. I think with many opportunities. So
Absolutely.
So I would like to thank you now for your insights. It was very good for you to explain a little bit who you are, what you do, and how you go about these modifications and alterations in the product lineup that you have. Is there anything you would like as a closing statement or any thoughts whatsoever?
Well, a good thing is customization is a nice thing to have, of course, because it keeps us busy. And I would say, just look around you regarding UV. Anything you see, almost every product, like iPads, telephones, bikes, screens, there's always somewhere an application that has been done with UV. So it's an incredible, interesting world, to be honest.
Yeah. So thanks again for being here. I hope to see you soon. And stay safe, stay healthy.
You too, Roland, and thank you for having me.
So my next guest is Stefan van Waalwijk van Doorn. He's a research engineer at TNO's Holst Center in Eindhoven. Welcome, Stefan.
Thank you, Roland. I'm very honored to be here. And I'm happy to talk a bit about what I know on this topic.
Okay, you're more than welcome, of course. We're both from the Brainport area, so it's a little bit of a home play, let's say. We first met at Hightech Excel with the Chiron startup, where we both joined to work on printing technologies.
Exactly.
So you're one of the founding team members. Could you do first a brief introduction about yourself?
Yes, of course. So my name is Stefan van Waalwijk van Doorn, and I'm a young researcher at TNO. So when I graduated from mechanical engineering here in Eindhoven, I started working directly at Holst Center. And maybe a little bit about TNO. So if you open and have a look at my first slide, TNO is basically a non-profit R&D organization which is spread out over the Netherlands and works on various different topics. And I work for a part called Holst Center, located in Eindhoven. And basically we focus on flexible electronics. And if you have a look at the left part of my slides, what I mean with flexible and freeform electronics is that we move from the electronics of today that you see in slide number 1, which are rigid, which are the typical PCBs with the components on top of them, towards more flexible, stretchable electronics, as you can see on the right. And next to that, I'm also working on, as you mentioned, for Chiron as a CTO. And there I'm basically one of the founders. And there we work towards bringing one of the developed technologies at the Holst Center towards the industry.
Yeah. So we are known in Eindhoven for the Brainport region, and in Brainport you have a couple of alliances and collaborations. And TNO is one of the parties that sits in the middle of that.
Exactly.
TNO is known for doing a lot of research on primary technology. So you have been part of that, and then out of that you branched out essentially to also work on the Chiron offering because
Yes.
you have this background in printing, right?
Exactly. So I can elaborate a little bit more on my work that I did at TNO. So
Mhm.
also from the pictures that I showed with a few examples, these are basically new kind of enabled applications, and these applications are enabled by working with new technologies. And typically in Whole Center we work on process knowledge. So for example, screen printing, inject printing, you can think of dispensing, 3D printing processes. We develop these processes even further and make therefore new applications possible. So you can think of that we work a lot on prototyping. And then at the point where we have to basically translate these new developed processes, these new technology, which was developed in research towards industry, so towards really mass production, that is the
Mhm.
part where we outsource it and we leave it to our partners and our industrial partners. So an example of what I worked on was I worked in a small group within the printed electronics group called New Printing Technologies. And there we worked on technologies which are not yet used in the industry. For example, one of those was Lyft technology, but also other methods of printing with light. So,
Right.
and a little bit more background on how we do that at Whole Center. So if you have a look at my third slide,
Mhm.
basically we work in a few different business cases and business models. The biggest one at the beginning of the opening of Whole Center was that it was a shared innovation center. So we work on open innovation, basically work with multiple partners together and do research together. And how this looks is basically you have an open consortium. Basically, everybody has a subscription to the research that is done, and everybody can use the research that is done. This was quite new compared to how the rest of TNO worked. They basically worked with dedicated projects. We still also do that at Whole Center, but a little bit less. And dedicated projects are basically as simple. An industrial partner comes to you with a question, with a problem, and needs research to solve the problem, to find a solution. And basically,
Mhm.
you work one on one. So you work together with the partner on finding the solution to that. And then we have the third way of working at the Whole Center, but also the rest of TNO, and that's basically once we have developed technology for a certain problem to be solved or for a certain partner, then it always leaves a lot of knowledge. It always leaves a lot of development that can also be used to solve other problems. And therefore, we also have the technology transfer program within TNO. And basically, they work on what can we do with the licenses, with all the IP that was developed. And a clear example is, for example, spin-offs. So
Yeah.
where a spin-off is being created from all technology that was developed for a certain reason, but can also be used for other solutions.
Yeah.
And that's basically also how we came to Chiron.
Yeah, because if you look at the session that you're now in, it's challenges in customization. From TNO perspective, that is slightly different than what you see with typical manufacturers that start off building a certain technology because they need to fulfill a certain requirement in the market.
Mm-hmm.
And with TNO, there's a lot of, let's say, byproduct almost
Exactly.
that still represents a huge value, but is not easily put into the market. And I believe you wanted to share the Chiron example as one of those technologies that already existed, but just needed that push towards a startup company that took it and bring it to market.
Yes, exactly. So like you said, indeed, there is a lot of byproducts at TNO research because there's a lot of research, there's a lot of IP being written, a lot of process knowledge being acquired, and basically once a project is finished, it has been paid for. There is this leftover, but it doesn't mean that the leftover will just be left on the shelf. But so what we do, and that's also why I want to make the typical example of Chiron, because I'm also a part of that, is what we did. We have a technology which was developed together with partners that was paid for in open research. So because it was in open research, it was still available for TNO. It was not sold off. It was used by other partners, but it can still be used by new partners. And what exactly happened there? So we have a technology called Lyft, and we basically formed a spin-off together with Excel. So on my slide, I can show you very quickly Chiron Printing Technologies, which was formed in the end of 2019, and working together with a venture builder, Excel here in Eindhoven, and TNO. We basically what we wanted to do was we became the enable innovation by making new microfabrication technology available to the industry. So the whole goal is to bring all this process knowledge that was developed in research together and form into machinery that can be used by the industry.
Yeah. So, and Lyft, when you say Lyft, then that's the abbreviation for laser-induced forward transfer.
Exactly. So
can you explain how that works?
Of course. So Lyft technology, a little bit of background about Lyft technology. So Lyft stands indeed for laser-induced forward transfer. Basically, it means that you use a laser, so you use light to transfer material from a donor substrate to a receiver. And I have here a very short animation of how this process looks like in the lab, so how it's typically done within research. And basically what you see is you start off with the coating of this thin layer, this donor layer that I mentioned. And that's basically the carrier of material that you want to print. And for example, compare it to inkjet or dispensing, you have a carrier with fluid that you want to push through a nozzle. But here you basically create this flat, thin layer. And then you place it upside down above whatever you want to print on. And then you focus the laser in any kind of digital pattern. So for example, here is a simple line being printed. And by focusing the laser in the thin layer of material, you create a very small push, gas expansion, and that creates a jet to be formed and transferring the material. So that's also why you call the name laser-induced forward transfer, by pushing the material forward towards you want to print it. And here in the example, you see a few antenna being printed. And basically, you have the freedom to do this with a lot more and higher range of viscosities. So for example, compared to inkjet, you can only work with low viscosity material because you have to push it through the nozzle and you have to form droplets. But with this method, you can also do it with high viscous material. So you have basically a much broader spectrum that you want to print with. So that's a little bit about the technology, how it works, the basics. And basically what Chiron has taken upon them is translating this thing towards machinery that can actually be used. Because you want people to be able to work with this technology without them having the in-depth knowledge of, for example, the laser and the material interaction. And they don't need to know all the details. They basically want to have a printer which can get a file in of a print and then can get exactly on top of what kind of product they would want to print the product out. So that's basically the goal and the reason why we formed Chiron Printing Technologies.
Yeah. So most of the audience is in the printing industry and is mainly concerned about inkjet technologies, or there's a certain kind of transfer technologies. You could look at this from a different perspective, where the application field might be completely different.
Yeah.
And it's still a certain form of printing. But it is going into an application field that is so different. Are there any challenges in transferring Lyft into a ready market product?
Yes, definitely. I would say one of the biggest challenges when you take upon, let's say, translating a process towards the industry is the first one is that the industry itself likes to work, as people like to work with technologies that they know. For example, technologies like screen printing, which have been around for hundreds of years. And because you are basically changing a very basic principle, because you're not printing with either masks or nozzle-based technologies, which are well known in the industry, like you mentioned, but you're basically using light to deposit material, which is something completely new. And if you do something completely new, we see that the big challenge is that people need to they need time. They need to get validation. They need to see other people using your technology. And as we are one of the first, we're not the only one, but we're one of the first bringing this kind of technology towards the industry. We basically have the biggest challenge of finding the people who want to take the risks of doing something new before they get the validations of others to be using it. And especially if you translate this to applications, is that if you use new technology, especially a quite complex technology, you have a lot of advantages that you get with this technology. And if you want to solve a problem for a certain application that already exists within a production line, typically what they would want to do is find a solution that is simple and easily being integrated in their production line.
Yeah.
But this is because you're basically changing a basic principle, which need quite a big machinery with new components, for example, the laser and everything, to be integrated. So you need to have the clear exact reasons, and you need to take advantage of most of the advantages that your technology brings. Otherwise, you're basically over selling to your customer. You're basically giving your customer more than they need. So I'd say that's one of the biggest challenges, linking them to applications. And that's also a reason why we typically look at very niche applications.
Such as?
So, for example, within the microfluidic industry, we're looking at applications where they really do not have technology solutions yet to create them. So you have really an enabling factor where you don't just solve a problem, but you actually enable a whole new part of the application to be built.
Right. Do you have a practical example of such an application?
Yes, of course. For example, if we compare it to the creating of screen printed applications with this technology, also as you can see in the slide, you have the clear advantages of having high speed, because you do not need to move nozzles or masks. You only need to move laser and light over a certain layer. So you have a very high speed that you can use, and you have the freedom of being in non-contact. So a very clear example of something that you could do with Lyft technology, but not with screen printing or inkjet printing, is that you can print over components. And over component printing is not possible with screen printing because it has to be in contact with the masks. And this is non-contact. And for example, to inkjet printing over quite large components, you cannot print with very low viscous materials because it will just flow down. And here you can work with higher viscous materials. You can create especially conductive connections over components.
Right. So we both know it's very interesting, and it holds a lot of promise for the future.
Yeah.
Our session here is a little bit too short to, let's say, cover all the details, and so I would probably like to ask our audience to connect with you separately after this session. On your profile page, they can find your contact details.
Definitely. For both Chiron and TNO offers and ideas, I'm happy to discuss anything with anyone.
Yeah. So for now, I would like to thank you for your insights and for your explanation of what TNO is doing and what Chiron is as a spin out of that.
Thank you.
And then, I hope to see you soon again.
Definitely, Ronald. Definitely. Thanks a lot.
So my next and last guest in this session is Robert van Dankeren. He's the CEO at the Brainport-based startup Infocal. Welcome, Robert.
Thank you, Roland. Nice to be here.
So the other guests in this session have been in the printing industry for quite some time. However, you are a startup. Could you maybe explain a little bit about yourself and the company?
Yes, of course. Like you mentioned, my name is Robert van Dankeren. My background is in physics, specifically material science and manipulation of materials with laser technology. And after working as a researcher and even as a software engineer for Philips, I spent the last dozen or so years in commercial management positions. And since June 2020, I've been part of the Infocal startup as the CEO. And like you said, we're a startup with the head office in the Eindhoven Brainport region. And we started our business as part of the High-Tech Excel venture building program.
Okay. So, what have you come up with? Because I understood that you have a novel approach to coding and marking.
Yes, that's correct. With Invoker, we have a revolutionary new type of laser technology at our disposal. And the idea came from one of the technology providers from HyterXL. And I can explain in detail what the technology is, but I think you'd be much more interested in the application of it. So let me get started with just the market that we chose to focus on because of the impact that we can have there, the marking industry. And what I always do is I use Coca-Cola as an example. So every day, Coca-Cola sells 1.8 billion bottles of cola. And all these bottles have an expiration date, which is printed on with ink on each and every bottle. Now, as a result, roughly 160 million liters of ink end up as pollutant in the environment. And the cartridges for this ink end up as landfill. And the carbon footprint of the production facility is quite huge due to the transport of this ink to and from this production facility. Now, the equipment itself also needs constant cleaning and maintenance, which heavily impacts the uptime of a production facility. For Coca-Cola, image was key, and being sustainable has always been one of their priorities. That's why they were investigating if they could change from inkjet to a new technology, and they looked into laser as an alternative. However, only Coca-Cola is one of the few production facilities currently doing this. And that is because compared to inkjet, laser marking is just not fast enough. Lasers can only work on surfaces in which they are completely in focus on that surface. So it gives you a very small range, and it only is one beam compared to the multiple channels that inkjet can provide. This is where our unique technology comes into play. We invented a revolutionary new kind of laser printer, capable of not only matching but actually even outperforming the current state-of-the-art inkjet technology. This technology is based on a groundbreaking optical principle. And as an example, here you can see how a normal laser beam looks like. Normal laser beams have a so-called Gaussian beam profile. With our unique technology, we are capable of changing this beam into what we call a concentric laser beam. And this unique laser beam has a major advantage over a normal laser beam. And that is compared to a normal laser beam, we can offer a focal depth which is over 400 times larger. Think, for instance, of a magnifying glass. If you use a magnifying glass to hit a piece of paper, only if you're exactly in the focus point of that magnifying glass will you see the effect. If you move the piece of paper even as little as 0.1 millimeter, it will lose its focus and you will no longer be able to heat the surface of that paper. With our technology, we can improve that range by a factor 400, meaning we can move it over a distance of several centimeters without it losing actual focus. Now, because of this longer focus range, we can actually start printing processes in production facilities a lot earlier, and we can continue a lot longer, since the window in which that beam is then in focus became a lot bigger. So therefore, we can actually print at much higher speeds and bigger surface, even compared to the current state-of-the-art inkjet technologies.
But this is really interesting. I assume that you've made a proof of concept. So you've tested and verified all of that.
Yes, when we first heard about this technology, we also thought this sounds actually too good to be true. So before we took their word for it, we decided let's do some simulations of our own and also look into experimenting. So we were able to build the first setup, which showcased that our technology is actually working. So we started with the simulations. We did some experiments to see if we can generate this concentric laser beam. And when we were able to do that, we started building the first setup and started marking surfaces with a longer focus range. We actually have a few videos that show that even if you move a curved surface into the direction of the beam over a distance of several centimeters, we can continue the printing process without it losing any focus.
Wow, that really looks amazing. So this also means then that you can have various distances, and it will just stay in focus.
Exactly. The technology itself is independent of the distance. So with normal lasers, you can already have a certain distance for the printing process. And we are flexible in that sense with what we can do with our technology. We don't need to be close to the surface to mark it, and we can even have a different distance and continue that marking process. Next to the technology no longer needing a consumable like ink, there are other benefits as well. Compared to inkjet, laser marking is a lasting technology. What we have seen, we talked to a lot of different production facilities, and they all complained of the same thing, and that is every once in a while a certain shipment gets rejected because the quality of the expiration date is so bad that it's no longer readable. And there are several different options and reasons for that. The easiest ones are items like the humidity in the production facility, or the storage warehouse where the product is being stored, or the temperature, which has a lot of impact as well. But one of the easiest examples that I can give is actually the way that that ink on the surface is capable of reacting with human skin. If you can just take a piece of plastic that you have in your refrigerator with some food being stored in it, which has an expiration date printed on it, that specific ink is very sensitive to the oil in human skin. If you can just use your own finger and rub your forehead or your nose, you can remove the entire expiration date in a matter of seconds. This quality level is something that a lot of production facilities are looking into to change, because this, as you can imagine, is quite harmful to them. It makes it difficult to trace their shipments. It makes it difficult to contain the level of quality that they provided with in the beginning. Yeah.
Yeah, so if I look at this, then it brings a lot of advantages for coding and marking. So it stays in focus. It's much faster. There's a precision to it, so you get rid of a lot of pollution in that supply chain. You said you are a startup. The proof of concept has been running. So is this already a ready to market product?
We're going there. We have set up the first R&D pilot with a company in Brazil, where we will build our first technology. And with that proof of principle in that production facility, we can showcase to other facilities that we have a technology and a system ready to operate in a production relevant environment. The goal is to have a few sales this year. We are currently developing our first alpha tooling for that. By the end of this year, we should be able to provide companies with a first full beta prototype to implement in their production facilities.
Okay. So, as a company, are you looking for something specifically? Do you search for partners, or do you want to go into, let's say, sampling and trialing for people in this industry?
Currently, as you mentioned, indeed, we are a startup. We are looking for collaboration. We think we have a technology that can potentially be a game changer in the marking industry. We're looking for partners that will help us to develop that technology to the next level, to be able to build the first set of systems and to make production facilities more durable and more sustainable, and making the environment a bit more friendly.
Okay.
So any company interested in joining us and helping us to develop this technology, I would be very welcome to talk to them.
Okay. So your information is available on the FuturePrint website. People can get in touch with you. So for now, I would like to thank you for your explanation of it, and I hope to be seeing a lot more of you.
Well, thank you. Thank you also for the opportunity to present myself and Infocal here at this platform, and I look forward to continuing.
Okay. So at the end of this session, we have a couple of our panel members to come together with some final thoughts about customization challenges in the printing industry. If I could ask Koen, when you look back at what the people have been saying, are there any thoughts that you want to share as sort of an endpoint to this session?
Yeah, so there's more customization from customers. There's more special products. That means that that people have to change, and also companies have to change every day. New applications, they pop up like mushrooms, so you have to go with the flow a little bit. Quick change, and I think that's the moral of the story. As a company, you have to react at this kind of speed. I think so, to go with the
Yeah.
flow.
Is that the same for you as well, Karsten?
Yes, I think we have seen here in a lot of different, or it's interesting to see different views with different fields in digitalization, in printing, and other adaptive manufacturing and everything. This is interesting to see that all have the same challenges: meeting customer requirements, building something for the customer, finding the niche, and finding the niche need. Sorry, the need, finding the niche and the need. I'm happy to be here with you all in the panel, and have the opportunity with Future Print to have that discussion here.
Yeah, for you too, it's slightly different because you are already vested names, of course, in the industry. For Stefan, how do you perceive it? Because as a newcomer, let's say startup in the printing industry, any thoughts about this session or the customization challenges?
Yes, definitely. So first of all, also want to thank everybody for being here in this future print summit. So thanks for inviting me, and especially what Koen said about change is directly applicable to me because I'm working for a startup as well, but also from research. The things that we want to do is bring the change. We want to bring new, innovative ideas towards the industry. While the industry typically don't want new things, they want to just go on with what they're doing and what they know that they're doing. So especially this change, I'm in the middle of bringing that especially to the future. And that's also one of the challenges of bringing a new technology, which we want to basically change what we want to do, want to change the basics of printing. So get rid of nozzle-based and get rid of mass-based technologies and really use light to print technology. And yeah, in order to do this, we see all the challenges, and especially because of this change that Koen mentioned.
Yeah, I can imagine that Karsten is not really saying he would like to get rid of all the nozzles in production.
Not necessarily. So there are so many multiple ways of creating surfaces. So for us, it's for human, it's making surface. Yeah, it's either a lamination, a pressing, a coating, or a printing. Yeah. So there are so multiple ways, and I'm very sure in the future there are other ways to create textures. And this is interesting. This is very interesting story. Creating surfaces. Yeah.
Yeah, that definitely there will be not, let's say, changed by getting rid of the old processes, but getting changed by introducing a lot of new processes, and everybody can then enable more new applications. And we, especially like mentioned before, the new applications will just grow and grow. And let's see what comes out of it. And which will win, but probably all of the technologies will win. But let's see.
Well, it doesn't matter, Stefan. So the world is changing. So also technologies are changing. Yeah? So that means you come with a new technology. Him has to implement the new technology in their machine. We have to come up with a UV solution that could basically, if you say we're going to replace the inkjet in the future, I hope it's going too fast, of course. But if it is, then there still are new opportunities for the coating, for the gluing application within the machine integration. So there will be always different ways of technology that will go side by side. So and also we it's not that we are saying, oh, there's a new technology that's gonna replace one market, but it also can open another opportunity for another market for us as well. Because I can imagine if you do something with changing the surface, it might need also an extra coating over that protect that against the weather or circumstances which have to be cured by UV. So in all ways, I think there's always an opportunity. It's up to you, the customer, if you want to see that opportunity. And new application.
Yeah, and basically find
So if I
complementary
would,
technology. Yeah, go
if I
on.
would just sort of wrap it up, because we're getting at the end of our entire session. I think that there's food for thought also between the different disciplines. People have seen the various stories of all of you. And for me, there's only one thing left to say, and it is to really thank you very much for your input, for your time. And I hope in post-COVID times that we can meet in person and then discuss all those opportunities live and in front of each other.